Okay, so here we are with Unit 9, Lesson number 3, and we're going to look at the third part of the title for this unit, which is salts. Now, we've already talked about salts a few times. Salts are ionic substances, which means they are composed of a metal and a nonmetal, which means you have an element from the left side of the table bonding to an element on the right side of the table. The metal becomes a positive ion because it loses electrons. The nonmetal becomes a negative ion because it gains electrons. They're both trying to get a stable octet. And you form something that is called a salt. Here are some examples of salts. The most common salt that we know of that you see a lot is NaCl. That's table salt, sodium chloride. Salts are formed during neutralization reactions, right? So if you wanted to form NaCl, if that was the salt that you wanted to form, you would have to have a base that has Na in it, along with an acid. And it would have to have Cl. So HCl plus NaOH would give you NaCl plus water. Here's an exception to the rule. Generally speaking, salts are neutral, but here's an exception where it would not be neutral because NH4 is a weak acid, which means it produces H pluses in solution. This is not something that you really need to worry about. Again, let's go through electrolytes. Again, as we said before, we said that there are all three of these are electrolytes, and you should be able to identify them, right? Acids have H in front, bases have OH, and salts have a metal and a nonmetal. They are all three electrolytes. There are substances that look like they're bases, but that's a little bit of trick to it. If something has an OH and it has carbon in it, then it's not a base, and you're going to see that later on. I think this, if you're not really sure what it means to be an electrolyte, I think this video kind of gives you a good idea of an animation of just exactly what an electrolyte is. So let's take a look at that.
An electrolyte is a substance that, when dissolved in water, results in a solution that can conduct electricity. The light bulb will light if a substance is an electrolyte. Sodium chloride, NaCl, is a soluble salt that is assumed to completely dissociate into ions. NaCl is a strong electrolyte when dissolved in water. The solution contains a large number of ions, and the light bulb is brightly lit. Polar water molecules interact with the positive and negative ions of the salt. The positive ends of the water molecules are attracted to the negative chloride ions. The negative ends of the water molecules are attracted to the positive sodium ions. This interaction between the water and the salt ion.
You should pay attention definitely to this diagram, this little part here. This is something we talk about in solutions, but this explains the process of dissolving or dissociation. So let me just rewind it a little bit and pay attention to what happens to the salt when you put it in water.
Polar water molecules interact with the positive and negative ions of the salt.
If you look at these water molecules, this red part represents the oxygen. That's the negative end, because remember, water is polar. It's a dipole. It has a negative end. So the negative end of the water molecules will be attracted to the positive sodium ions. The other end of the water molecule, where the hydrogens are positive. So the positive ends, like you'll see here, will be attracted to the negative chloride ions and pull that chloride ion away. This water molecule will pull the Na plus away, basically picking it apart until the entire salt is just individual ions.
Positive ends of the water molecules are attracted to the negative chloride ions. The negative ends of the water molecules are attracted to the positive sodium ions. This interaction between the water and the salt ions causes the salt to break apart or dissolve in water. Hydrofluoric acid, HF, is a weak acid which only partially ionizes in water. HF is a weak electrolyte. The solution contains only a small number of ions, therefore the solution is weakly conducting and the light bulb is dimly lit. At equilibrium, a hydrofluoric acid solution contains mostly non-ionized acid molecules, HF, and a small amount of hydrogen ions, H+, and the conjugate base ion, F-. Methanol, CH3OH, does not dissociate into ions when dissolved in water. It is a non-electrolyte. A non-electrolyte solution does not contain ion.
It's a non-electrolyte because it is covalently bonded. Notice that CH3OH contains only nonmetals. And generally speaking, except for acids, covalent substances, molecular substances, do not conduct electricity because they do not break apart into ions. And here's an example.
Therefore, the solution does not conduct electricity and the light bulb does not light. Methanol molecules contain a polar OH group. The oxygen has a partial negative charge and the hydrogen has a partial positive charge. This charge separation is called a dipole. Methanol molecules are attracted to each other through the interaction of the dipole of one molecule with the dipole of another molecule. Water is also polar and the dipole of water will interact with the dipole of methanol. These particular dipole-dipole attractions are called hydrogen bonds. The attractions between water molecules and the methanol molecule will break the attractions between methanol molecules, causing methanol to dissolve in water. Note that upon dissolving, the covalent methanol molecules remain intact. Compare this to the dissolution of an ionic compound such as sodium chloride, NaCl, which breaks apart into its component ions in water.
Okay, so that's it for lesson number